Hi distinguished students, once again you are welcome to our lesson series Math 106. Today's lesson topic shall be probability concept. Hope you will enjoy the topic as we go along. You are welcome. As you well know, my name is Dr. Derek Anjorin from the Department of Mathematics, Lagos State University. Objective of the lesson. At the end of this lesson, you are expected to know 1. Various types of elementary probabilities. 2. Generate sample space of events. And 3. Calculate probability of points in the sample space. In this lesson, you will be introduced to some basic elementary probability concepts. Some of these concepts will be pictorial in nature. Also, you shall come across various ways of arranging objects called objects. The method which is known as permutation and the applications to probability concept. Some basic definition of and examples. Probability is the tendency to show the degree which you believe in something. Experiment. This is any operation whose outcome is not subjective, unpredictable with throwing a die, tossing a coin, lottery outcome. These are some events that are probabilistic. Trial and event. A trial and event experiment is a single performance of the experiment. The number of trials in any given event, say X, is denoted by NX. Outcome. An outcome of an experiment is one of the possible results from a trial of the experiment. Sample space. The sample space X is of an experiment Y is the set of all outcomes of one trial of the experiment, and each outcome can then be called a sample point. Event. An event A is any subject of the sample space. A is contained in S. A is a subset of X. Example 1.1. Obtain the sample space of tossing 3 coins together. 2. Obtain the events that 2 heads appear false in 2 trials. Solution. The sample space displays a ball HHH, HHT up till TTT. The events that 2 heads occur, tails appear false is A, HHH, HHT, TTH, TTT. You can see that A is contained in X. From here, the probability of an event A shall be defined and show that it is represented qualitatively. The probability of an event A in a sample space X is the ratio of the total number of favorable outcomes to the total number of all possible outcomes, and is denoted by P of A, where P of A is equal to expression in 1.01. Example 1 above, that the probability of an event A above. What is the probability of an event A? 2. At least one head in the outcome. 3. Double H or double T. What you need to do in this space is to list the sample space and know the number of points in the sample space. Then the probability of each event will be the number of events that occur divided by the total number of points in the sample space. For 1, n of A is 5. By definition 1.16. So we have P of A will be 5 divided by 8. At least double heads occur in the same space is the event A, and the n of A is 6. The total sample space is 8. So P of A in that case is 6 over 8 is 2 over 4. 3. At least one head H occur. The sample space is given by that, and the probability is half. Basic property of probability. Generally, event can happen in any finite number of ways. Say n out of total capital N possible equal likely ways. The probability of occurrence by the event is denoted by P of A equals small n over total n. If A denotes the number of success, A complement shall denote the number of failure. Then P of A complement will be n minus small n divided by big N. Mutual exclusive events. This means that the occurrence of one of the event includes the possibility of occurrence of the other one of the same trial. In all cases, you note that P of A is greater than 0 always. So P of A is 0 less than P of A is 1. And P of 0 is less than P of A complement is also less than 1. This means the probability of events in a given sample space always takes the value between 0 and 1. You should note that P of A complement is 1 minus P of A, where C denotes complement in set A. A basic law addition. P of A1 plus A2 is the same as P of A1 plus P of A2, where A1 and A2 are events. If A1 and A2 are non-mutually exclusive, then P of A1 plus P of A2 is P of A1 plus P of A2 minus P of A1 intersection P of A2. Sometimes the symbol of union can be interchanged for plus. Example, a box contains 3 black, 4 yellow and 2 green balls. A ball is drawn at random from the box. Determine the probability that the ball taken is green, the second is yellow, the third one either black or yellow, fourth neither black nor or yellow. Solution. Find the probability formula you have for P of A1. For question 1, you have it to be 2/9. The other one is 4/9. The third one is 7. You add because of the or, you add the two probabilities are 7/9. Now P of A union 4, the P of A union A complement A2 union A3 complement will be 1 minus P of A2 union A3 by definition, and that will give you 2/9. Determine the probability of a number chosen at random from integers between 0 and 16 inclusive. 1 a multiple of 4, 2 a multiple of 3, a multiple of 3 or 4. Now you exhibit the sample space X, which is between 0 and 16, and this is an example of non-mutually exclusive type. Now A1 multiple of 4, the n of A is what? 4, number of points. So A2 a multiple of 3, n of A there is 5, n of A2 there is 5. So you have for P of A1 will be 4/17, P of A2 will be 5/17, and since you have the word neither here, then look for P of A1 A2 complement. By definition, that will give you 9/17. Also, in the case where they are not mutually exclusive, you have by definition the probability to be 8/17. Multiplication law of probability. The symbol intersection reads as could be substituted for word and or vis-a-vis. Given events A and B together, the probability of two events is denoted by P of A1 and intersection P of A2, which is P of A1 and intersection P of A2. Also, you can generalize this intersection as it is in expression 1.08. P of A1 intersection A2 intersection A3 up to intersection AN can be written as P of A1 times P of A2 times P of A3 up to times P of AN. Example: there are three balls, red, yellow, and white. The probability of these balls hitting a target, 1/3, 1/3, and 1/4 respectively. Determine one. All the balls hit the target. Only the yellow ball hits the target. None of the balls hit the target. Now you apply the definition of probability as we have a ball. For the first one, you have multiplication. All the balls hit equal, so that is intersection. You have 1/5. For the second one, this is also as defined before. This will give you for intersection problem. That was also multiplication. You take the complement and multiply the respective expressions. You have probability to be 1/10. Conditional probability. A conditional probability is the probability of one event if another event occurs. Consider the toss of a die. The probability of event A, 3 heads occur, is P of A 1/6 on a simple toss. Given event B containing at least 3 heads, should occur. In this case, there are only 4 possible outcomes, one of which is the probability of A3 is 1/4. Given the event B 3, 4, 5, 6 occurred, the conditional probability of A given B is denoted as P of A by B, which P of A by B is equal to P of A intersection B divided by P of B. If event A is independent of B, the conditional probability of A given B is the same as probability of A. That is, P of A given B is equal to P of A. Multiplication for intersection. Multiplication, the probability of 2 events A and B which both occur is obtained by multiplication rule. P of A intersection B is same as P of A times P of B given A, which is same as P of B P of A given B. If A and B are independent, then P of A intersection B is equal to P of A times B. A bag contains 3 red balls and 2 white balls. The 2 balls are drawn one after the other and without replacement. Obtain the probability where that a white ball is drawn at the second time, given that a red ball was drawn the first time. B, drawn in the red-white, of drawing a red-white ball in that order. C, of drawing a red ball. Applying the given probability definition as we had for the first one, you have the probability to be half. For the second question, applying the other one, because there is intersection, you have the probability to be 3/11. Then P of red ball is 2. You have the following activities need to perform. Standing less. Some conclusion, you have a good knowledge of how to generate sample space, how to calculate the probability of each event that may arise from the sample space. You have the following references for my student, hope you really enjoy this lesson. If those problems given to you are actually done and you consult the references given to you, you have a good understanding of this lesson. Go back. Thank you.